So I'm Bob Root-Bernstein. I'm the platypus. I think you'll see why in a moment. I mix all sorts of things which aren't supposed to quite go together. All right, so I'm going to give you three different takes on some of the projects that I do. One of them came out as something my wife and I wrote as a book called Sparks of Genius, the 13 Thinking Tools of the World's Most Creative People. This project emerged from a study I originally did on scientists, asking them how they came up with their creative ideas. They kept talking about fairly obvious things like observing, but then they start talking about abstracting, empathizing, body thinking, dimensional thinking, all sorts of things which we do not teach explicitly in any course. I would run back to my wife and tell her about these, gee, I just ran across this scientist who defines abstracting just like an artist did. And then she would sit there and say, well, I just came across this guy who says the same thing, but he's a poet or a dancer or whatever. Eventually we said, we have to put this together and explain to people that everybody's using the same mental toolkit. So basically the book describes in 13 chapters the 13 thinking tools. We all observe, we all have to abstract out the key information from those things. We find patterns in those, or we have to imagine new kinds of patterns. We empathize, we get into things. I mean, scientists literally become a cell, or they become a neutron star, or they get into their patient if they're a doctor, or things like that. So you can see the whole list here. The interesting thing, as I said, is none of these things are explicit in any of our teaching, and yet we all do these. So it's simply a book trying to say there is a language and there are a set of cognitive skills that we all share that can bring us all together. Just to give you one example for medicine, analogizing. Analogizing is finding connections between things, not in terms of how they look, but how they function, and they can function in ways that are quite surprising. So when Earl Bakken wanted to come up with a heart pacemaker, he actually comes up with it by analogy to an electronic metronome, because the metronome puts out a sound. He says, what if I put out, instead of a sound, an electrical pulse, and that goes directly to the heart. So that's the origins of that invention. A second aspect of this is that, again, my wife and I, and Anya Pothik, who is a student here in medical school, also getting a PhD in neurosciences. She's also a competitive ballroom dancer. She teaches yoga. Okay, you can see why we captured her to help with these kinds of projects. So we've been trying to look at how you can teach these things formally. So for a group called SEED, Science, Engineering, Art, and Design, which was funded by NSF, we undertook a project to evaluate what the research says about best practices. What is the evidence that putting arts and sciences or medicine or any of these things together is actually valuable? So part one of the study, which is online, I'm happy to send to any of you a link to any of these things. The first part is all about what's the evidence this is worth doing, that is actually beneficial to a doctor or beneficial to a scientist or beneficial to an artist to actually engage in these things. Part two is best practice in the actual classroom, and I'm happy to say to this group that the vast majority of really well done studies have been done in medical and dental schools. Dentists and physicians understand and have used most of the arts through the 13 thinking tools, as it turns out, that I just mentioned, in very explicit ways. So if you want to have a good guide to how to do this, it's there. We've reviewed it. This is where you can start. And then the third part is new directions. Where should we be going with the research? So if you want to look at the possibilities to develop this kind of pedagogy further, that's the third part. The third project that I've been working on should be finished this summer. It's a book called Modern Leonardos, Artists, Musicians, and Performers as Scientists and Inventors. One of the things that my wife and I kept running across when we go out and lecture about these things is, if the arts are so important to the sciences and medicine and so forth, why don't the artists make discoveries? Now, it sounds like a really stupid kind of argument, okay, but people will, when threatened with a new way of thinking, go back and find some way to entrench themselves. But I thought, what it would, if you could actually respond to that and say, well, they do. And so I started looking. It turns out there are at least 200 good examples of really fundamental types of discoveries and inventions that have been made. I'm not even going to try and give you a taste of them. I'm just going to give you about 3 or 4 here. Anybody who's involved in cardiology will probably have heard of René Leannec. He invents the stethoscope. He also was a flautist. This is a self-portrait. Is that a flute or is that a stethoscope? I think he literally drew it that way so that you wouldn't know, because the two not only look very similar but can be functioned very similarly. And the music there is not music. That is in his book describing to physicians how to listen to the heartbeat. He expected at the time he wrote that everybody actually would know music, could read music, and would be able to hear what it was he was talking about. Here's a set of 3 slides which are sort of related. Alexis Carrel won a Nobel Prize for inventing the methods by which you can actually stitch together large vessels. It led to the ability for us to actually do organ transplants and so forth. He did this literally by taking the methods of lace making directly into the surgical room. Okay, he formally trained with the best lace makers in France. Today we're still doing this. There's a guy named Julian Ellis. If you go online, look up Julian Ellis, you will find that his embroidery company makes bespoke surgical implants. So you have major surgery on, say, your shoulder, and they need to reconstruct everything, tie everything back together. He can embroider something made out of materials that will disappear over time, which will allow the surgeon to put everything back together. These are much better than all the other implants that have existed, because one of the things that's neat about embroidery or weaving or the other fabric arts is fabrics can move in every direction. Plastics and things like that don't, they're rigid. So this is a huge new breakthrough in just the last few years. And if you don't have the money to do this, you can still use these techniques. So here's a guy, Franz Freudenthal, who works down in Bolivia and in Peru. They have a very large number of literally kids born with holes in their heart. The only thing you can do for these kids is to go in and literally plug the hole. But to plug the hole, you have to have a little occluder which is exactly the right size for that kid's heart. How do you have these made when you have no resources and no money? So he goes and he finds a bunch of Bolivian women who are great at knitting. They literally knit these occluders out of metal. They sterilize them. Each one's made for an individual patient, and they stick them in. So you can literally say that there is art at the heart of medicine. Thank you.